This is part of the first presentation is part of an architecture track. So hopefully you folks are technical, like technology, kind of in that space, because that's what we're going to try and focus on here for the next 4 presentations in a row. I'm Matt Tavis. I'm a principal solutions architect. So generally what I do is actually work with customers out in the field, give them advice about what they can and can't do on top of the AWS platform, what works, what doesn't, what other customers have tried. Every once in a while, marketing will tap me to come and do events like this where I then speak and try and summarize what we've seen out in the field and to help you guys get a sense for what works, what doesn't, and what we've seen. This particular presentation is really more about general tenets and concepts around architecting for the cloud. The idea being that, while you can forklift and take an existing app and just say, well, I'm going to try and forklift it and just run it like that on top of the AWS platform, there are some benefits and some things to think about if you're thinking about rewriting or even maybe doing some minor redesign of an application to run on top of a cloud-based platform. So I want to run through that, and hopefully it'll at least spark some conversations in your head. And then if we finish a little early, I can take a couple questions, but we may go all the way to the end of time. We'll see how it goes. Sound good? All right. The good thing about this whole discussion is that actually all of these concepts and everything we're going to talk about here are actually also encompassed in a white paper on Amazon.com. So you can actually see at AmazonWebServices.com Cloud Computing Best Practices. Actually, if you just go to /whitepapers under the AWS.Amazon.com domain, you'll see a whole list of white papers, and this is included in there. So a lot of these concepts are sort of beefed up a little bit in that presentation, so you can read more about it. So there you go. The first thing we tend to like to talk about when we talk about architecture is really what are some attributes of what cloud computing is. The reason why this kind of is important is because it helps you sort of maybe rethink some traditional approaches and sort of what is this cloud, what does it offer me in general. And then we'll sort of jump into what sort of the architectural concepts you might want to think about when building for it. The first thing to think about is that what we're dealing with here are abstract resources. We're not talking about, while there are obviously fixed server sizes, for EC2, you can add disk, on the fly to something like that. You can stop and start an instance and resize it from, a small to a large, from a large to a quadruple extra large, right? So when you think about what you need for an application, instead of thinking about a server footprint or a particular configuration that you're mapping to or building for, think about what abstract resources you need for that particular workload, right? It could be CPU bound. You might need a high CPU instance. It could be it could be I/O bound. You might need to add multiple drives and stripe across them, right? It could be network I/O bound. You might want to go for a larger instance type. It could be memory bound. You might want to pick a different server size, right, that has more memory footprint, right? So there's all these things, and so instead of thinking about the server footprint you're building against, thinking about rather the resources you might need. That's the first kind of subtle shift that occurs. One of the next things is really about it being on demand. Fundamentally, this is obviously Amazon's perspective, Amazon Web Services perspective on cloud computing. The idea is that it should be on demand. When you need it, ask for it. When you don't need it, get rid of it, right? It should be much more of an on-demand kind of a model. That allows you to sort of actually work with something that scales in and out dynamically. The ability to actually leverage the resources as you need them and pay for what you need, right? And obviously, if it's on demand, that's great. It doesn't do anything if it's not, in a reasonable time frame. So scalability within minutes. The idea here is that when you say on demand, that means I can hit a button 3 minutes later, 5 minutes later, I can have a server spinning up, running, ready to take requests. I can have an additional drive attached to that server. That's kind of the scalability model that we think about, not just on demand, but also, in order to respond to real-time events. And then, of course, another fundamental feeling about the model for us is that it's really about pay for consumption. Just like, your electricity bill varies every month based on whether you ran the toaster more often that month or decided to turn on the AC, your compute bill, your storage bill, your network bill can vary each month because you needed more or less resources for that particular month, or you needed more resources for less resources for a particular day. And so our fundamental belief system here is that it really is a pay for what you use, as opposed to, necessarily a fixed cost, right? And then, of course, the one thing that we like to highlight about, the value of a cloud computing platform is that you're actually leveraging the efficiency of people that have been building data centers for years. This is a business we got into, Amazon.com and Amazon Web Services, out of necessity. We had to build up these large data centers. We had to have the ability to manage large-scale infrastructure to support, our retail systems in the mid-90s, right? So this is expertise we built up. It was fundamental. There wasn't, the capability to sort of outsource that based on the scale that we were trying to actually achieve. Nowadays, we recognize we have that expertise, so we might as well actually repackage it. But that expertise isn't necessarily something everyone needs. Not everyone necessarily needs to focus on building data centers. So the opportunity here is to leverage somebody else's time they've spent building data centers and move on to more business-focused activities that actually are driving value for you and your customers, right? So what's in this whole cloud? Yeah, obviously, we've had a lot of overview of the platform. I'm going to quickly just map some of our services back to what you might need to build or design an application. So the first thing you're going to need, obviously, is compute. This is where Amazon EC2 comes in, 11 different server types that you can choose from, in terms of sizes, resources. Go ahead and pick what you need, fire it up, go, right? We also offer both in a standard format where everything's much more publicly accessible, also a virtual private cloud offering where you can have your own private network overlay, so you can have your own 10 dot private IP range that you're managing within. So those are both, compute-based services and offerings. On top of that, you need storage. So we have a whole bunch of different storage offerings. S3, about objects, blobs, images, videos, static objects, CSVs, backup files, database dumps. Simple DB domains, which is much more in the NoSQL vein. So if you're familiar with that space, it's sort of a big table, highly indexed, flexible schema. That's, a solution for certain data structures and data access models. EBS volumes and their snapshots. EBS is on-demand, network-attached storage. I have a server. I want 1 terabyte drive. Okay, snap one on. I need another one. Allocate a new one. Attach it. Right. Block storage, network-attached. Very quick to allocate and attach. And then, of course, we have more structured storage offerings like Amazon RDS, which is really a relational database in a box. You go ahead and allocate one. We make sure we manage it, run it, back it up, maintain it. You can, by APIs, resize it, add more storage, make it on a bigger box, make it multiple availability zone based so it actually has a master-slave configuration, create read replicas. All that's sort of baked into that service as an API set that you can access. In the messaging world, so let's say you need coordination between components. We have both a queue-based model, so a simple queue service. So if you want to do workflow coordination, passing messages, workers pick it up. SQS is a common use case there. Or then more pub-sub. So I want to put a message onto a topic and then blast it out to a whole bunch of downstream consumers. So both messaging models are in there through 2 different services that we offer. We also offer payment services. We have a PCI Level 1 compliant payment gateway service that allows you to actually do B2B, B2C, C2C type exchanges of payment through the platform, so you can leverage that as well. And then if you need to distribute your content, right? It's great that it comes out of that server out of, say, Virginia or San Francisco. But hey, guess what? I'd really love to have that, closer to my customer. I want it served out of, Atlanta or something like that. You can actually use our CloudFront content distribution network, and then you get edge caching of your static content or streaming content closer to your customer base. And then, of course, for scale, obviously, these things are great. When we talk about leveraging cloud scale, you need some services to help you with that. We have things like auto scaling, which can resize your fleet dynamically, both out and back in, as well as load balancing for dynamic distribution of requests across a fleet of servers. And then CloudWatch is our monitoring service that allows you to collect metrics across all of your resources so you can see what's going on across the whole platform. And then, of course, analytics. You may need to analyze what's going on in this environment. We actually have a Hadoop-based MapReduce cluster that we actually manage for you, so you can actually put your data in S3 and then go ahead and spin up a MapReduce job on top of that, and we'll manage spinning up the cluster, doing the processing, spitting the results back out to something like S3, and then you can analyze all the data that's being collected from all these various services, right? And of course, identity and access management is key. Security is always a piece, so we do have a whole layer at the bottom that covers all these services underneath that allows you to create your own accounts, create your own account rules, ACLs around those accounts. Developers can start servers but can't stop them, whereas admins can do both. You can actually control access for individual AWS accounts to allow you to have much more fine-grained control over who can access what resources or at what APIs, fundamentally. That's kind of the 5-minute overview of the entire platform. As you can tell, there's a lot of pieces there, a lot of moving parts, a lot of choices to make. But fundamentally, this is a quick, 10,000-foot view of the platform as a whole. So when people talk about scalability, They often will talk about one aspect or another. Fundamentally, there's one thing that I want to make sure we always cover up front when you talk about scalability. Scalability, in my mind, in our mind, is a contract between your architecture and your infrastructure, right? So if you have an incredibly scalable software architecture, but you're trapped in a single rack of servers, you're trapped by the scalability of that physical footprint, right? The flip side is also true. If you have access to something incredibly scalable like the Amazon Web Services cloud, but your software architecture has bottlenecks baked into it, you're not scalable either. So the two have to work together. How you build your software to be scalable and the infrastructure that supports it, both of those have to work together in order for you to get true scalability in the platform. So just sort of a meta point to make sure that, and that's where a lot of these tenets come from, is how to build software that allows you to achieve the scalability you might need or want on top of your application. So I'll run through each of these in general, but there's seven different architecture lessons learned. Some of these are our own that we've learned from our own Amazon.com experience and Amazon Web Services experience, but others are actually ones that come from customers. We'll run through each of these. The first one is incredibly pessimistic at a certain level, but it's also very true, right? Over time, everything fails, right? Fundamentally, software fails, hardware fails. You didn't design for something, you didn't plan for something. Requirements change. The new requirements break the system. Things do break. So thinking early and often about how to design around failure and how to anticipate failure within the software and hardware architecture actually gives you the flexibility to survive many issues that might come up along the way. The reason why this is interesting, this is obviously true, in the physical world, not even the virtual world. This is just a generally true point for almost anything that you might be doing today. But in the cloud, what's interesting about it is that you actually have the ability to respond to this slightly differently. So if you think about the physical world, if a server goes strange, starts behaving badly, you're like, I don't know what's going on. You gotta page somebody. You gotta get a tech in there. Somebody's got to actually figure it out. They got to debug the problem. They got to bring it back online. They got to fix it right away, right? In a cloud-based model, you can just throw it away and replace it with a new server and move on, right? So it sounds like, well, but there's some there's some state there. There's some application knowledge there, and we'll cover some of how you get back to where you were in this a few tenets from now. But fundamentally, the way to think about it is you may be able to respond completely differently. You may be able to actually spin up a new server, bring a new web server, app server into rotation, have it dynamically put itself into the load balancing, and then you never page a tech. Everything just moves on. It just starts functioning again. Now, if you care about what happened to that server and why it went wonky, that's great. But then what you can do is you can put it in the corner. You can maybe stop it, put it over in the corner, and then you can actually debug it later. But that's not necessarily what you want to be doing when you think about serving customer needs, right? You want to be getting that customer access again immediately to the system. So the ability to rip and replace and move on and actually spin up new infrastructure, replacement infrastructure, changes how you might think about how you respond to real-time events that are occurring from a failure perspective. Obviously, things like avoiding single points of failure makes a ton of sense. We have some, features that you can obviously have warm, hot standbys. You can have pre-positioned machine images that have all the configuration you need, and you can just spin it up, and 3 minutes later you've got a new one. We have elastic IPs that allow you to reroute public internet traffic or even traffic inside the data center to another server by simply remapping that IP to a different machine. So there's techniques that are available inside this environment that allow you to respond very differently than you might have responded in a traditional data center model. Oh, yes?
Here you're in your example, you're using hardware failure, which I would assume would be more you as vendors, cloud vendors' responsibility than the customer. So how does it, if the machine that the virtual server happens to be running on goes belly up, how does Amazon respond to that? So
Sure, great question. So the question was, it's a hardware failure. Isn't that really AWS's responsibility since we're managing and running that infrastructure? So that's a great question. I think trying to make a single node within an architecture or a single node within any kind of physical infrastructure completely and totally failure resilient isn't a realistic approach. We sort of had that experience over the years in running Amazon.com that if you try and work on making one node perfect, you're going to end up spending so much time and money that actually it's diminishing returns fundamentally. So thinking about how to actually make those nodes actually agnostic of one another, how they fail and move on, is actually a much more efficient and effective architectural model. And so, yeah, you're right, it does put work on the software developer to actually think about how to respond to that, but it gives you ultimately a system which is much more flexible and resilient to the changing over time. Now, how we respond to it is if that server dies and we see that, we'll go ahead and obviously go and replace it. We have people running around the data center 24/7, ripping and replacing bad drives, pulling out controllers and things like that and taking care of that. So we'll get that box into rotation again, but for you can stop it and move it over here to another physical box with a simple API call. And that's a much more efficient model for you to get moving faster. Waiting for us to rip and replace your box is actually a lot slower than having your software respond to it dynamically. So I think it's a way to think about it. Yeah?
For your service, is hardware, high availability come with it by default, or do you have to purchase that?
So the question was, does service hardware high availability come with it by default, or is that a separate purchase? So the So the way to think about it is that what we're trying to focus on giving you is the ability to make infrastructure changes at a highly available level. So if you look at our SLAs, they focus on the availability of our APIs to manage your infrastructure, not a single node in the infrastructure, right? So the way to think about that is how to design your high availability should be built into your application and how it responds. And then if something fails, you can spin up replacement infrastructure quickly and dynamically. It's not about that server or that single node or that single drive. It's about the access to an incredibly vast array of servers and drives that you can rip and replace through API calls. Is a way to think about it. So I don't want to take too many questions up front. I'm sorry. Hold on. Just because I want to get through some of these, and then what I'll do is I'll open it up again. Does that make sense? Okay. Sorry about that. I saw the floodgates opening. I saw the hands shooting up, and I'm like, all right, it's not like I don't want to answer the questions, but if I get through one lesson learned, I didn't do my job. I get in trouble. Janesh will report me. So the next one is about loose coupling. And so for those of you who are big fans of service-oriented architecture or SOA, this is pretty much a rip-off of that whole concept, the idea that really when you design systems, you should design them to be black boxes. Components within that architecture are black boxes. They don't make assumptions about the next layer in that component. And the reason why this is interesting is because it actually changes the way you can lay out and scale your infrastructure. So if you have black boxes that are running around in your architecture, the web server doesn't really know much about the app server other than its contract. The app server just knows the contract into a data service layer, right? That means you can scale each of those layers independently. It means you can actually decide to say, oh, well, you know what? My web servers, have a completely different load profile than my app servers. They need completely different resources. They need completely different scaling characteristics based on user traffic. Right, so having that intentional decoupling between components or layers allows you to have a completely different scaling model. It also opens you up to hybrid models. And this is actually where a lot of folks sort of start when they think about how am I going to move to the cloud. They say, well, I've got a whole bunch of work happening in this application. And maybe some of it is asynchronous and is actually batch processing that's going on. You could move some of that workload completely off to a different data center in a different system, coordinate the whole thing with queues, and then at the end of the day, what you've done is you've given yourself a whole bunch of new scale because you've actually decoupled layers within your architecture. It's a fairly fundamental software change, but at the same time, it actually gives you a lot more flexibility in terms of deployment, layout, replacement of components, scaling. So thinking about how to decouple those layers such that they're sharing things only like contract and not necessarily, where they are or any kind of guarantees around availability will help you kind of leverage some of this elastic and flexible infrastructure either in the data center or even across the cloud. This is the first one. Implementing elasticity is the first one that actually is truly, I would say, cloud-oriented. And this is really goes back to that first point. We said, hey, let's go ahead and plan for failure. Well, great. You plan for failure. You decided, well, web servers, app servers are not critical. I'm going to go ahead and spin up a replacement. Well, that's great. How does it get into rotation? How does it know what to do? How does it know how to communicate with the other components within your architecture? This is that first stumbling block of saying, well, I'm going to go ahead and design for failure, and I'm going to auto-replace things, or I'm going to auto-scale my infrastructure. The challenge there is then thinking about how does my software know what to do when a new web server, a new app server come online, right? And in some cases, this is really easy. Things like our elastic load balancing service, it's an API call to add a server behind it. If you use our auto-scaling service, when we add a new box, it knows what load balancer you're using. It'll just put it right behind that load balancer, right? In other cases, it may be work that you're doing, maybe a database master-slave failover configuration, or maybe it's spinning up a new read replica in your architecture. But fundamentally, at some point in that software architecture that's totally embracing this flexible infrastructure, you're going to deal with how do I actually, make that machine work within the actual infrastructure. And one of the key pieces that we see folks doing is actually pulling in configuration management platforms, things like Chef or Puppet, dynamic configuration platforms, where the first thing that box does, you pass in some metadata when you launch it and say, all right, well, the metadata is, here's the location of the configuration management server. That's all you tell it. And it says the configuration management server, hey, I'm a web server. What do I do? And it says, oh, well, install this script, run this command, fire up this web server, go get the code from S3, pull all this, coordinate yourself, then put yourself behind the load balancer. Or it gets auto put behind the load balancer, and once all that configuration is done, it turns on the page that satisfies the health check for the load balancer. Right? So it's really thinking about how do I make this application dynamic. And in many cases, this is often a change in the software platform, where somewhere in that software architecture, there was a config file. There's always some config file somewhere. And the question is, what do you do with that config file, in this kind of an environment? And a lot of times that config file needs to be created on demand at launch, real time, because where your servers are, how they should talk to each other, is something that can change over time. So thinking about how to embed that into the software architecture is another key piece, and it allows you that flexibility through the platform. Security. Security comes up a lot. Obviously, it's something people focus on. They want to know more about it. And our fundamental belief system is that security belongs in every layer, at every component, right? And that means it's not just at the edge. It's not some firewall that somebody configures and takes care of it. It's really how you think about locking down the architecture, component by component, instance by instance, environment by environment. And so the way to think about that, we have a lot of features around that, things like security groups that allow you to lock down, the network ports and protocols even available to be talked to on that instance. But on top of that, you can add your own layers on top. If you want to do intrusion detection systems, you can install those in the actual machine image. If you want to do IP filtering, you can obviously use things like IP tables. Encryption comes up a lot. You can encrypt your data at rest through encrypted file systems, or encrypting data before you store it in something like S3. S3 just actually launched a server-side encryption feature as well. So if you want S3 to encrypt it for you, they can do that. And then in transit, between nodes. You may say, this is super sensitive data. I want to make sure it's protected. I'm going to use SSL or TLS even between the instances inside the environment. Right, so how you choose to layer software security or application security on top is up to you. But fundamentally, these are all things that you can do on top of the infrastructure. But thinking through that is definitely a key piece, and allows you to actually lock down the environment specific to your security profile and what your application needs, as opposed to sort of a generic approach. And of course, we have features, in terms of using identity and access management to prevent, access to developers who maybe shouldn't see certain buckets in S3 but should see others, or shouldn't be able to do certain things like changing security group configurations. These are things that, you can actually go ahead and lock down in terms of how you give people access to the infrastructure and the environment, right? This is an example of, what it looks like, one example of security group for the canonical three-tier, architecture, right? Here at the web security group, I've opened port 80 and 443 of the world, right? So that means all my internet traffic comes happily into here. Interestingly, for my app security layer, I've actually opened port 8080, my Tomcat port, but only to my web security group. So with security groups, you can tier them. So it allows you to say, I'm going to lock down this port and protocol to be, must be coming from a machine in this security group on that port and protocol. So that means that this traffic is totally allowed. Right? But if you try to hit, if somebody tries to come in directly on port 8080, it's not going to work because it's not coming from the right source IP address, right? And we check that on every packet, right? Same thing down here in the DB security group, 3306 is open to the app layer, right? Now, of course, you may say, that's great, but what about administration? How do I administer these machines? Well, a simple model is to say, I'm going to use the corporate office. I'm going to use the IP range, the public IP NAT range of this corporate office, and I'm going to allow port 22 SSH access into this environment, right? Right, so here we go. We can go ahead and set the security group. Here's an IP range, a CIDR address, /16 address that represents my corporate IP range, and that's allows port 22 in. Now, I don't allow port 22 into any of the other boxes because I want to actually manage from a particular administration layer. So I do allow port 22, though, from the app layer. So you can bounce back up into the web servers and then down into the DB layer, right? So they can actually talk to each other on 22, but direct access could be limited to one or a handful of boxes, right? And then, of course, there's scenarios where I might have some third-party database vendor who's going to do some administration. well, I can lock it down and give 3306 directly to that specific IP all the way down to an exact IP I expect, right? So you can actually replicate the same kind of network layering that you might expect in a traditional, data center model, three-tier, multi-firewall DMZ in this kind of a security group configuration as well. This is one that actually comes up a lot for folks that are newer to the platform. I think once you sort of play with it a little bit, it starts to make a little more sense. And once you start embracing some of the ideas of abstract resources, it becomes easier to sort of move past this point. But a lot of folks will look and they'll compare their server list, with our server list and go, well, I've got, 128 gigs of RAM server over here. You don't have one of those. Clearly, this isn't going to fit, right, as an example. And that's not necessarily always the case. There may be software changes necessary. This may be, a single node that's a caching server that, you have to think about partitioning to bring it to the platform. But fundamentally, there are definitely cases where you can actually make those changes. And what you may find by breaking some of those constraints is you can actually optimize your consumption of resources, right? It may be that you're using a 128 gig box because, you have one of them and everyone's piling onto that one machine. And then it turns out by making a software change to split into multiple machines, you can actually use smaller boxes and maybe even use less of them for some of the time, actually optimizing your resource footprint, right? So sometimes I went to one big vertical, large box actually is hurting you from a total cost of ownership perspective because it's getting low utilization. If you can split, you can actually optimize how you might use resources in this environment. So this one, is definitely it's a choice to be made. It's a software change. But at the same time, it actually allows you to possibly embrace a more flexible infrastructure where you're growing and shrinking dynamically. And then the last one is thinking parallel. And this comes up a lot. It's very similar type to maybe the database, large database type model where somebody is saying, hey, I've got a huge data warehouse node that I want to migrate, and it's some monstrous box that everyone's pounding on to do my month end kind of calculations or analysis. Well, it may turn out that actually that's a job that maybe doesn't belong on a single node or a single database. In fact, there may be ways to parallelize that kind of work. So we see a lot of folks looking at things like Elastic MapReduce, which is our MapReduce managed MapReduce cluster, that to allow you to take data warehousing jobs that normally would have been hammering on one very large clustered database node to actually spread that over tens or even hundreds of smaller nodes to actually do that same processing and spit out the answer much more efficiently than actually choosing to go for one large, extremely large verticalized instance type. So definitely ways to think about it. Obviously, a lot of these last two oftentimes are big paradigm shifts from an algorithmic perspective and from a software perspective. But I think the benefit of doing it in that approach as opposed to sticking with the somewhat underutilized or often underutilized large box actually can really pay off in the long run. And then, of course, we have a ton of different storage options, and there's a reason why. Over the years, from Amazon.com, in terms of how we built things, how we designed the platform, we've discovered a lot of different needs for storage, different access patterns. Lots of readers, one writer, right? Lots of readers and writers, but really, really small bits of data, right? Things that are just a big table that I just need to read really fast. Things that are just cached and are not transient. I don't need them, for long periods of time. So we've actually built services around them for those specific scenarios. So we have things like S3 for blob storage, CloudFront for content distribution. You can see the list here. And they actually are all fundamentally useful in different scenarios. So you have to sort of look through your data and your data access patterns and think about what's the right choice for each particular configuration. And right choice for that data set. So that is definitely something that we harp on a lot when we talk about architectural approaches, because no two data sets are equal, no two ways in which you access them are the same. So thinking about how you manage them is definitely key. And this is the eye chart, which you can't even read because it goes off to the side, which is awesome. But you can see here's basically what they're good for, some canonical examples, the things that are not recommended for, or things that are they all recommended for, or not recommended for, and then some examples of that. So this is an eye chart. This will be available for you to read later, so if you're trying to take a picture from the back, don't bother. You can't even zoom big enough to get it. So this will be in the decks which you're going to make online, so you can take a look at it some more. It just gives you a sense of kind of there's a large matrix, and in fact there's a whole talk on storage options, which Joe Barron's going to be doing later today, that'll cover a lot of this content, right? So I'm going to stop here, Because instead of applying them, it sounds like there was a lot of questions in the room, and I'd rather actually get folks answers to some of those as opposed to diving into a specific example here. I saw questions earlier. You still have them, right? Yes, okay.
As an implementation guy, as opposed to a designer,
Sure.
a lot of what I see here is intriguing, and I've got things spinning around in my head. But one of the big features of what you're discussing and referring to are things that I'll even say you can come back to me offline if necessary. But I would also imagine that there's, I'm going to be representing vendors.
Right.
Vendors have
Mm-hmm.
awareness
Mm-hmm.
and present me with a certain opportunity to do things
Right.
well in this environment, and then there are other ones who are going to have, a different take on that.
Sure.
So,
Sure.
what have you seen and experienced to date in the types of systems that are out there that lend themselves to this, or vendors that are out there that are particularly problematic?
I think the question is really sort of, what vendors, what types of systems fit well in this kind of environment? What have we seen that works well? It'll sound cliched at a certain level, but gee, almost anything could work. I think there are certain types of scenarios that if you told me that you wanted to do that, I might steer you away from. So you want to do like real time, microsecond latency trading on, say, NASDAQ. I wouldn't do that here because we're not next to NASDAQ. Those guys are in the same data center. That's an example of something that doesn't work.
Like CRM, like assembling with
Yeah.
a CRM solution. I'm doing some
Yeah.
scalability
Mhm.
around an ERP or an HR
Yep.
solution. Is that kind of information disseminated enough? And I wouldn't try to have all
Sure.
that answered now, but
Yep.
within your teams,
Mhm.
if we come to you or whoever our representative is and say, look,
Yeah.
here's what we're thinking about.
Totally.
Can you give us some guidance, and even if some carte blanche, if you had some ideas about we really wanted to leverage the architecture, but honestly, I got a vendor decision to make.
Yep.
And I'm going to need some help.
No, so the question was, are there things like CRM, ERP, HR systems that work well? But is it, what's the kind of the leeway you have as an implementer to use it? And fundamentally, we're giving you a toolkit, right? This is, think of this as the amazing craftsman toolkit. You could build a Formula One racing car from scratch out of this thing, or you could build a Yugo. It's your choice. Now, that being said, you do have a lot of flexibility. There are a lot of applications that, are built in a certain way that your only option is maybe forklifting that and running it in a very similar type and managed infrastructure as you might run in a physical data center, because you don't have control over all the bits that you might want to do to enable leveraging all these lessons learned. In other cases, it makes sense from a cost-benefit analysis to go in and crack the code or make some changes to the infrastructure. So, you are given flexibility in this platform. What we're trying to provide you is a toolkit and a platform that you can use to do what is appropriate for your customer.
Well, in your point,
Right.
I have one massive server, and I'd like to go into a broken, more
Yeah.
distributed
Mhm.
architecture, but my software application vendor says I got to use one node.
Sure, exactly, and that's the kind of thing where, if you're locked into a single node model for software vendor reasons, then that's what you're locked into. And so in that case, the answer is, well, see if you can forklift that one. Right, and that's it.
I don't want to steal a vendor.
Yeah, no, fine.
During transition, let's say we have an Oracle database running on our system, and we want to port it to the cloud.
Yep.
It doesn't always just lift and
Sure.
What kind of, with a contract with AWS, what kind of support do you provide for transitional issues?
Yeah, so the question was, I want to transition an existing Oracle database. It doesn't just lift and drop into the cloud. What kind of support do we provide? That's fundamentally part of what my role is as a solutions architect. What I would do if I were in your case is I'd say, look, I've got a customer. I'd reach out to, my sales rep on the AWS side. He would pull in myself or someone like me to provide you kind of the architectural advice around how you could make that work or some of the challenges you'll face. On top of that, we have a partner team that works with all of the ISVs. And so, we have a great relationship with Oracle. We have folks that are tied into the Oracle database folks, directly inside the company. And so, when it comes to figuring out whether something will work or not, I would hook you up with, as an example, Jamie Kinney, who's a guy who has a great relationship, used to even work at Oracle, can help, debug some of those challenges or help point you in the right direction on what the right architecture is there. And then, from an operational perspective, not transitional but operational, we do have a support platform that can help debug real-time issues with the infrastructure itself. One more question. Yes.
As far as VPC, what are some of the tool sets going to be available inside of VPC, like load balancer, RDS?
Yeah.
What are those, and the ability to tie in EC2 security groups into VCL for VPC?
Right.
Are those on the roadmap, or are they?
Yeah. So the question was, what are some of the features coming along the roadmap for VPC relative to the entire AWS platform. So VPC has a limited support in terms of all the services it supports today. Things that we've already pre-announced are things like Elastic Load Balancer support, RDS support, Elastic MapReduce are things that we're going to focus on making available as part of VPC. I don't have explicit dates for you on that, but those are definitely shorter term items. And then I know that people already brought up the idea of tying EC2 security groups into VPC security groups and linking those together. That also is something the team is looking at. So I don't have dates for you here and now, but maybe we could chat after. I can get your email and we can talk about it. Yeah. All right, I lied. One more question. Yeah. You want to take a look? Oh, sorry. You want to go back? He just wants to go back and read it. Cool, that works. I can let you do that. Yeah. Cool. Well, thank you very much. I don't want to cut everyone off. I know that there's lots of good questions. There'll be more sessions today. I want to make sure I transition over to the next speaker, but I will be out in the hallway after this, not to steal Janesh's thunder. He's a good talker too. But if you do have something pressing you want to talk to me, I'll be outside in 2 seconds. Sound good? Thank you.